Hello. I didn't expect to see you all here. We're if I'm here, that means we're probably building an app, right? Now, have you ever actually gone ahead and built an app? It's surprisingly challenging. Not only do you have to learn the tools and programs to actually go ahead and build the app, then you got to go ahead and start scaffolding out the app, figuring out where all your data is coming from, actually build out some of the UI, and then you have to go ahead and build out more UI. Sometimes some UI is contextual. Sometimes it's only going to be shown on certain device sizes. Sometimes it's only going to be shown on certain device types. You have to build the UI again. And then you have to build some more UI. Even though you are building for mobile, sometimes we have larger form factors like a tablet that needs adjusted UI to fit that scale and that dimensions that our users are used to working with. Now, imagine doing this once, challenges arise. We now need to go ahead and do this two additional more times to make three UI designs for our users. This is not ideal. All these platforms, whether it's iOS, Android, and the web, have their own common design patterns and their own tools and techniques for building out an app. There are ways to alleviate this. We could go ahead and use a popular cross-platform solution. The only problem is that some cross-platform solutions are not as cross-platform as they advertise. For instance, some of the ones that people are probably familiar with only focus more or less on iOS and Android. The web, it's kind of an afterthought, and even then, it's still a limited version of the web. You're not able to use existing libraries that you may know and love for the fact that it now needs to exist in this kind of uh, weird pseudo web context, but also be able to run in native. It's not ideal. The more ideal solution would be have something where you could have your web code, your iOS code, and your Android code all coexisting and being able to share the components across all of them. I'm here. I'm probably going to be talking about it. So we're going to be talking about Capacitor, which is the cross-platform solution, which allows us to share all of our code across all the platforms. Now, how this works is a fascinating technical deep dive, but to kind of summarize it, Capacitor works by taking your existing web app and packaging it up in this native shell. Now, this native shell has access to all of the same native features that any of the other cross platform solutions have, but also allows you to integrate with the native native device features and third party SDKs pretty seamlessly. So, if you're deploying to iOS, you can access the native SDKs available there. Same way with Android. And on the web, we're able to provide either a fallback or utilize JavaScript SDKs that exist there. Now, the way this is done is through a very complex kind of solution of parsing out JavaScript code, passing it to a native runtime, but that is kind of beyond the point. The real point is that this is all provided to you through a very simplified TypeScript API. The APIs that you use to, say, target the status bar or the launch image are all done through a unified API. So that way you're not having to deal with the complexities of how is this done in iOS, how is this done on Android, and how is this done on the web. Now, this is all well and good, but let's actually go ahead and see a real example here. So this is an app that I've been working on for a little bit. It is a Blue Sky client, an alternative to Twitter these days. And I want to go ahead and package this up and ship it as an iOS app. Well, there's a few ways that we can do this. First and foremost, we want to go ahead and install the necessary packages. So we're going to install at capacitor core and at capacitor CLI. This will give us access to the core runtime as well as the CLI needed to execute further commands. Now, this I've already installed, so we're not having to wait for npm here. But then we can go ahead and run npx cap init. This is going to go ahead and create us a new capacitor config file, which will be our basis for configuring all of the native projects. In fact, let's take a look at what that looks like. Now, this is just a TypeScript file. You can see we are exporting this config. It has the app ID, the app name, the directory where it should be pulling in your web app, and then some server information here and there for how to configure the native projects. In fact, we can go ahead and configure plugins here as well. So that way, if we wanted to just hard code some information to a plugin, we can do it before it even has to access the native code. So with this installed, we can then run and add the native platforms. In this case, let's install at Capacitor iOS and at Capacitor Android. So we'll go ahead and, like previous commands, install the native packages that we need from here, and then we can run npx cap add iOS. Now, I've already done this, so let's go ahead and just open up the iOS project. We'll run npx cap open iOS. And here we are inside of Xcode. Don't be too intimidated. But you can see that we have a native app delegate.swift where we can take a look at some Swift code. If we want to modify this project, we can take a look at the web assets that we have going on here, our launch screen, some of our asset catalogs, and then the main storyboard for actually presenting the app. So if we want to, say, go ahead and extend this with a custom third-party view, we could do that as well and kind of mix and blend what is native and what is web. But for most of our cases, this is just a simple app. Let's go ahead and run this. We'll go ahead and we'll hit the play button, which is our way of building and then deploying. It's going to deploy to an iPhone 14 Pro Max. We'll give it a little second right here. And here we are. We have the iPhone 14 booting up. So let's go ahead and log in. Then we'll sign in. And then we have our app. But we notice there's something different going on here. Good thing is that because this is still using a web app at the end of the day, we have access to all of our typical dev servers that we're used to doing in the browser. So let's go ahead and we're going to open up a new terminal. We'll do ionic cap run iOS, and we're going to pass in this live reload flag, which will go ahead and connect our simulator with our dev server. This will go ahead and do a quick little update. So let's just let this run in the background. And cool, here we go. Our app is up and running. Let's go ahead and fix this UI real quick. So we'll go to the component that has this issue, and I know it just needs a header. So we'll add our header toolbar, and then inside of this, we'll just add a title with, we'll just say home for now, and then we'll save. And here we are. Our app is already updated. It looks just perfect on our iPhone. And if we come over to our browser again, we can reload and hey, our UI is automatically updated. In fact, we can go ahead and change this to, let's go to feed and have this update both the native app and the web app at the same exact time. So we're already getting really fast with our update cycles and being able to add new features. If we want to go ahead and actually access, say, the native UI bar, so this native status area over here, this is as simple as importing the module that we need. So in this case, we're importing the status bar, and then we're going to import the status bar object. Inside of the status bar, we have a few different methods available to us, but you can see that we have hide, show, get info, set style, background colors. All of these are native methods available to the status bar that we can call through TypeScript. Let's go ahead and set hide, and then we'll have a set timeout, and we'll just say status bar dot show, and we'll call this after 2 seconds. So let's go ahead and write this. So it'll hide, and then 2 seconds later, it'll show. Now, notice that the browser didn't freak out, didn't throw any errors, or didn't crash because of the calling this method. It'll gracefully fall back if a API isn't available inside of certain runtime. So if you're calling, say, Face ID, and that's not available on a older iPhone or on an Android device, you can gracefully handle those situations when they arise. So let's wrap up and go back to our situation we had before, where we had 3 different UIs. Not really something that we want to be doing. We don't want to build the app multiple times or have situations where we are building our apps for some devices and then having a compromised version for the other one. Instead, we can build our app once and deploy it to all these different platforms and still have access to native features and still have a pretty fast app. So this is Capacitor. You should check it out. It's at capacitorjs.com. And thank you so much for hanging out with me today. Cheers.